In this video, we will look at creating nested loops in your code. In Mobius, you can create nested loops by nesting for each statements and while statements. A basic example of a nested loop is shown. It consists of two for each loops. The POSIS variable contains a list of positions. To see the list ordering, you can select the Show Geometric Entities toggle button. Then in the attribute table for positions, make sure that the column called POSIS has the eye toggle switched on. This will show the list ordering in the 3D viewer. As you can see, the positions are listed in column order in the Y direction. Here, we have switched the order of the two for each loops. In this case, the outer loop iterates over the Y values, and the inner loop iterates over the X values. As you can see, the positions are now listed in row order, in the X direction. The for each lines of code have a print toggle button on the right-hand side. Printing can give you a better understand of the dynamics of the nested loops. Switching on the print toggle for the outer loop prints the X value 3 times. This is because the outer loop only iterates over 3 values. Switching on the print toggle for the inner loop prints the Y values 15 times. This is because the inner loop is executed 3 times by the outer loop. Each time it is executed, it iterates over 5 values. So in total, the inner loop iterates 15 times. You can also switch on the print toggle for both loops. This will print both X and Y values. An X value is printed 3 times. A Y value is printed 15 times. Let's have a look at another example. Another way of using nested loops is for iterating over nested data structures. Nested data structures are very common. An example is a list of lists. A good example of a list of lists is the output returned by the pattern.grid function. Here, the function is generating a grid of positions, 5 by 5 in size. So a total of 25 positions will get generated. In the function parameters, if you select rows, the function will generate sublists that are rows of positions, in the X direction. In the function parameters, if you select columns, the function will generate sublists that are columns of positions, in the Y direction. Let's generate a bigger grid. This will make the patterns more visible. Here, the function is generating a grid of positions, 20 by 20 in size. So a total of 400 positions will get generated. In the function parameters, rows is selected. The nested loop now iterates over this nested data structure. The outer loop creates the I index that gets used to select each row. The inner loop creates the J index that gets used to select each position in the row. The two indexes are used to extract a position out of the data structure and then extrude it. Notice that the height of extrusion is short on the left side and get higher on the right. This is because the height of extrusion is actually set to the variable J. Next, let's have a look at how you can use break and continue statements in your loops. A break statement allows you to exit a loop prematurely. Break statements can be used in both for each loops and while loops. In both cases it does the same thing. It forces execution to exit the loop and continue with and code below the loop. Here is an example. The outer loop starts to execute. But when it reaches the position number 12, the variable I will have a value higher than 10. The break statement then kicks in. As soon as the statement is executed, execution will exit the outer loop. You can see that in the model, the positions in the top rows are not extruded. This is because these rows have an I index that is greater than 10. In this example, the break statement is inside the inner loop. When the inner loop starts to execute, it will iterate over the row of positions. This time, when it reaches the position number 12, the variable J will have a value higher than 10, again, the break statement then kicks in. As soon as it is executed, execution will exit the inner loop. However, it will not exit the outer loop. This means that execution will return to the outer loop and continue with the next row. In this case, we have two break statements, one in the outer loop and one in the inner loop. Both break statements are executed at different points. The break statement in the inner loop is executed 11 times. Each time, execution will return to the outer loop. The break statement in the outer loop is executed 1 time. A continue statement allows you to move execution back to the top of the loop. Break statements can be used in both for each loops and while loops. In both cases it does the same thing. It will force execution to skip any subsequent lines of code in the body of the loop. Execution will return to the top of the loop and start on the next iteration. Here is another example. The outer loop starts to execute, but the variable I will have a value less than 5. Each time this happens, the continue statement kicks in. When the statement is executed, execution will return to the top of the outer loop. You can see that in the model, the positions in the bottom rows are not extruded. This is because these rows have an I index that is less than 5. In this example, the continue statement is inside the inner loop. When the inner loop starts to execute, it will iterate over the row of positions. This time, for the first 5 positions, the variable j will have a value less than 5. Each time the continue statement then kicks in, and execution will return to the top of the inner loop. Here is the same example again. But the condition for executing the continue statement has been inverted. As a result, the last 15 positions of each row are not extruded. In this case, we have 2 continue statements, one in the outer loop and one in the inner loop. Both statements are executed at different points. The continue statement in the inner loop is executed 15 times. The continue statement in the outer loop is executed 5 times. That covers break and continue statements. Next, we will look at iterating over entity hierarchies. When working with geometric models, it is often necessary to iterate over lists of geometric entities. If these entities have some kind of internal structure, then it may also be necessary to iterate over entity hierarchies. In Mobius, this is common. In this example, we start with a polyhedron, consisting of a set of polygons. The outer for each will loop over the polygons. The inner for each will loop over the edges of each polygon. In the inner for each statement, you can see the expression to get all the edges of a polygon. In the main body of the inner for each loop, certain edges are selected and extruded. The logic of selecting the edges is based on the angle between the edge vector and the z vector. If the angle is less than 30 degrees, or greater than 150 degrees, the edge will be extruded.